Now that we understand why salted hashes are so important and why this is a good way of implementing passwords if we're doing it ourselves, let's take a look at how we can actually do this at a code level. We'll be using a library called bcrypt to do a lot of our cryptography for us. This will take our passwords and one-way hash them into a hash. This algorithm is pretty good, at least right now in 2019, and allows us to not have to worry about things like creating salts and doing a lot of this hard work. By the way, this is a good time to mention how to install these dependencies. We've done a lot of this for you to this point, but for your final project, we will expect you to be installing and setting up your environments a little bit more on your own. To install a new dependency, we simply use npm i with the dependency name, followed by save to save it to our local package.json file. We're also going to be including types for some of our dependencies. So for bcrypt, we can npm i with save dev flag, which will save it to our developer dependencies, with @types bcrypt to save our types for this library. Getting back on track, let's take a look at what bcrypt looks like, what interfaces it provides. So we're going to be salting and hashing our functions. We have our plain text password that we're going to be saving as a string. This is a very strong password, which I'm not a cat person. I have dogs, but I assume cat people like to call their cats Sir Cat thing for whatever reason. We then have some additional information here to salt that. So there's a concept of salt rounds. For bcrypt, what this is doing, it's an iterative algorithm. So the more rounds you have, the better jumbled up your stuff's going to get. This is actually 2 to the power of salt rounds, so it's happening a lot, 1024 times. So basically, we are taking our password, or rather, we're generating a salt, and we're going to jumble that up a whole bunch of times under the hood with bcrypt. We use our library bcrypt.gensalt, telling it the number of times we want to jumble, and that'll be saved as our variable salt. We'll then create our hash by using bcrypt hash, which takes in a password and our salt to generate that hash. Finally, when we want to compare to see whether or not our password matches our hash at runtime, at comparison time, we can use bcrypt.compare to check those two things. This is the output of logging these variables. So we've got our plain text password, we've generated a random salt, and then our hash will include that random salt as the first part. So we don't have to save this separately in our database, we just have to save the hash, and it will very nicely handle this for us. Some of the stuff at the beginning tells us what format our hash is in so that bcrypt can make sense of it later, which is a really nifty thing that gives us a little bit of less work and less overhead. And then finally at the end is the hash that will be dependent on our password. But again, since our salt is so long and we have such a nice long thing that we're appending, guessing the rest of your password to get to the same hash will take a lot of time for someone who is trying to do something bad. If we ran this a few new times, our salt will start to change. And you'll see the first bit, the information about how we're saving stuff is going to be consistent, but everything at the end is a totally new random salt. And as a result, our hash will also be different. So even with the same plain text password, each time we generate our hash, our final bits of our hash will change. This is why it's so important to generate a new hash every time a user changes or creates a password, so that we're confident that our hash is entirely jumbled and secure.